Hello students, welcome to Anne's classes. Let's do squares and square roots, properties of square numbers. We are doing exercise 3C from page number 50. Question 2. Seeing the value of the digit at the units place, state which of the following can be square of a number. Just by looking at the digit in the units place. So let's underline the digit in the units place. Here's 1, 2, 4, 8 and 9. Just by looking at the digit in the units place, we need to say which of the following can be the square of a number. Now we have learned the properties. It's very important that we know all the properties well. So based on that property, let me write that property. Square numbers always end with the digits 0, 1, 4, 5, 6 or 9. That means in the units place, you will have one of these digits if it is a perfect square. So let's see which of these which of these numbers have 0, 1, 4, 5, 6 or 9. So here we have 1. That means this number can be the square of a number. It is the square of a number. Then 2, no, we don't have 2 here. As you can see, we don't have 2 here. So this cannot be the square of a number. So let's cross it out. This cannot be the square. Next one is 4. So 4 is here. That means it can be the square of a number. Next one is 8. The digit in the ones place is 8 and we don't have 8 here. That means this cannot be the square of a number. Next one, it's ending in 9 or the units digit is 9. That means we have 9 here. So this can be the square of a number. So what is our answer here? The first one, the third one and the fifth one are the answers here. So the first, third and fifth are numbers that can be the square of other numbers. So remember to apply the property. Question 3. Squares of which of the following numbers will have 1 at their units place? That means these are all the numbers. If we have to square them up, which of the squares will have 1 at their units place? Again, we have to remember the property which says if a number has 1 or 9 in its units place, then its square will have 1 in the units place. So let's look out for numbers that have 1 or 9 in the units place. So 81 has 1 in the units place. That means this one square will have 1. Okay, so 81 square will have 1 in the units place. Then we have to look for a number that has 9 in the units place. That is this number. So here, third one, 139 has 9 in the units place. That means that one square will have 1 in the units place. You can also check this way. Here, 7 is in the units place. The square of 7, 7 sevens are 49, isn't it? Square of 7 is 49. That means 1 is not there in the units place. Look at the next one here. In the units place, we have 1. 1 ones are 1. 1 into 1 is 1. So this has 1 in the units place. Then let's go to the next one. 9. 9 into 9 is 81. And 81 has 1 in the units place. Go to the next one. 3 is in the units place. 3 into 3 is 9. We don't have 1 in the units place. Go to the next one. 4 is in the units place. 4 fours are 16. We don't have 1 in the units place. So you can do it this way also. Try and remember the property, but you can also check this way. Question 4. Which of the following numbers will not have 1 at the units place? That means 32 square. Will it have 1 or not in its units place? So which of the following numbers will not have 1? That means if a number does not have 1 or 9 in its units place, its square also will not have 1. So if it doesn't have 1, does it have 1 here? No. So this one square will not have 1 in the units place. So this is the first answer. Now is the number ending in 1 or 9? No. So this also will not have 1 in its units place. Next one. Is the number ending in 1 or 9? Yes, it's ending in 9. In the units place, you have 9. That means the square will have 1. Here they're saying will not have 1. You have to look for a number which will not have 1. So this number, because it's ending in 9, it will have 1 in its units place. This number is ending in 1. It will have 1 in its units place. This is 265. The number is not ending in 1 or 9. That means in the units place you don't have 1 or 9. That means this will not have 1 as its in its units place. So what is the answer here? The first number, the second and the fifth one. They will not have 1 in their units place. Question 5. Squares of which of the following numbers will not have 6 in their units place? So we have 5 numbers here. How do we know if we square it up that the answer is not going to be 6? You don't have to actually square it up, use the property. If a number does not have 4 or 6 in its units place, so if there is no 4 or 6 in its units place, then its square will not have 6 in the units place. So here 35, there is no 4 or 6. So this one will not have 6 in its units place. Next one is 23. In the units place we have 3. It is not 4 or 6. So this will not have 6 as its square. So that's the answer. Next one here, the units digit is 4. That means the square will be 6. Here the units digit is 6. That means the square will be 6. Here the units digit is 8. That means the square will not be 6. So again here this is the answer, first, second and the fifth ones. Another way of checking this is by looking at the units place here. So here we have 5. Let's multiply and see. 5 5s are 25. So what do we have in the units place here? 5. The question is which are the numbers which don't have 6? So this number doesn't have 6. Go to the next one. Units place we have 3. 3 into 3 is 9. It doesn't have 6. So this is the answer. Now next one is 4. Multiply 4 into 4. 4 4s are 16. This has 6 in the units place. Again take the units place here. 6 into 6 is 36. It has 6 in the units place. Take the next one, 8. 8 into 8 is 64. This does not have 6 in the units place. So this is another way of checking. You can actually multiply the digit in the units place to get your answer. Question 6. Which of the following numbers will have 6 in their units place? So we have all these numbers. Now if a number has 4 or 6 in its units place, its square also will have 6. So look for numbers that have 4 or 6 in its units place. Here there is 6, 26. In the units place you have 6. That means the square will have 6. So that's the first answer. Second one, in the units place of 49, we have 9. It is not 4 or 6. So it will not have 6 in its units place. Third one, 34. In the units place, we have 4. That means its square will have 6 in the units place. Next one, 43. Here 3 is the units place. So it's not 4 or 6. So it will not have 6 as a square in its units place. Then 244. So here in the units place we have 4. If we have 4, then its square will always have 6 in the units place. So this is also the answer. So what are the answers here? First one, third one and the fifth one. Another way of doing this is by actually checking the number in the units place. So here let's look at the first digit or the digit in the units place. We have 6. So 6 into 6 is 36. The question is which of the following numbers will have 6? So this number has 6 in the units place. Take the next one. 9 into 9 is 81. This does not have 6 in the units place. Take the next one. 4. 4 into 4 is 16. It has 6 in the units place. Take the next one. 3. 3 into 3 is 9. It's not 6 in the units place. Next one is 4. 4 into 4 is 16. So, and 6 is in the units place. So this is another way of doing it apart from your property. Question 7. If a number ends with 3 zeros, how many zeros will its square have? So 3 zeros means n number of zeros. So the square will have 2n number of zeros. So if n is 3, isn't it? So 2n will be, so n is 3, 2n is 2 into n, which is 2 into 3, which is 6. So there are 6 zeros. So double, you just have to double it. There will be 6 zeros. Next one, if the square of a number ends in 10 zeros. So here Then already the square is given. So the square of a number has 10 zeros. So how many zeros will the number have? Okay, so here in this question we are told a number has so many zeros. How many zeros will its square have? Here we are told the square has so many zeros. How many zeros will the number have? So here it is 2n. That means n will be half of this, half of 10, which is 5. Half of 10 is 5. You just have to divide 10 by 2. Next one. Is it possible for the square of a number to end with 5 zeros? Is it possible? It's not possible because always the squares of numbers will end in even number of zeros. So the answer is no. First you say, is it possible? No, it is not possible. What is the reason? The reason is the number of zeros at the end of a square number is always even, and 5 is not an even number. 5 is an odd number, so it's not possible for a square to have 5 zeros. Next one, give reason to show that none of the numbers given below is a perfect square. So 4 numbers are given here, none of them are perfect squares. What is the reason? A number having 2, 3, 7 or 8 in its units place is never a perfect square. So let's see here, 2, 3, 7 and 8. So these numbers have these 2, 3, 7 and 8 in its units place. That's why they are not perfect squares, because if they are perfect squares, they shouldn't have these numbers in its units place. That is the reason. Question 11. State whether the square of the following numbers is even or odd. Okay, so here we've been given numbers. Now the square, if we take the square of this number, is it going to be even or odd? If we take the square of this number, is it going to be even or odd? That's the question. Now let's take the first one. So the first one is 23. Now the square of 23, is it going to be even or odd? If it's an even number, the square will be even. If it's an odd number, the square will be odd. So this is an odd number. Still, 23 is an odd number. So the square will be odd. So let's write that. The square will be odd. It's an odd number. Next one is 54. And 54 is an even number. So its square also will be even. So let's write that. Square is also even. Next number is 76. And this is an even number, so its square is also an even number. The next number is 75, which is an odd number, so its square is also odd. So that's easy. If the number is odd, the square is odd. If the number is even, the square is even. Question 12. Give reason to show that none of the numbers, that means the numbers given here, there are 3 numbers given, and they're saying that none of these numbers is a perfect square. And what is the reason? So they've already told us it's not a perfect square. What is the reason? So what we'll do is let's count the zeros. So here there is 1 0, here 1 2 3 zeros, here 1 2 3 4 5 zeros. So can you see the number of zeros is odd? It's an odd number. 1 3 5, they are odd numbers, and we know very well the squares of numbers have to be, if they end in zeros, the zeros have to be an even number. So none of the numbers is a perfect square, because a perfect square number will always have an even number of zeros. So here the number of zeros are odd numbers, so they're not perfect squares. Question 13, let's evaluate. Now this is a simple one. Again, we learned this as a property. You don't have to multiply this twice and this twice. Instead, straight away you can say 37 plus 36. That will give you your answer. And that is 73. So when you add up these two numbers, you get 73. Now how did we get this? Now this is a property that we have learned. So this is n plus 1. So 36 plus 1, 37. The squares, when you subtract, the answer will simply be this number plus this number. That's why we added 37 plus 36. And you will get this. Now if you actually work this out, 37 into 37, get your answer. 36 into 36, get your answer. When you minus both, you will get 73. So you don't have to do that. You don't have to waste your time multiplying. You just have to apply the property. So this is n. This is n plus 1. The squares of both when you subtract, the answer is n plus 1 plus n. Okay, it's the same thing. So we just have to add up this instead of working this out. Next one is also the same thing. This is n, 84. This is 84 plus 1, that is 85. So your answer when you work out this will be 85 plus 84. You just have to add it up. This will be 169. So this is our answer, 169. See how easily we got the answer without actually multiplying and finding the difference. Next one, here we have 101 square minus 100 square. Can you see this is n and this is n plus 1. 100 plus 1, the squares of both. When you find the difference, all you have to do is add both 101 plus 100. So this will be 201. See how easily we got our answer? This is by applying the seventh property. Question 14. Without doing the actual addition, find the sum of these numbers. Okay, so here we have a lot of numbers. Look carefully and see 1, 3, 5, 7, 9. Can you see they're all odd numbers? And we learnt that to find the sum of the first few natural odd numbers will be just by counting the number of numbers there are and then finding the square of that. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 odd natural numbers. So the answer is 12 square. You just have to find out how many there are and square that up. So 12 into 12 is 144. So without actually adding, we found out that the sum of all these numbers is 144. So if you actually add them up, you will get 144 and this is our answer. So all you have to do is count how many numbers there are and find the square of that number. That is your answer. Question 2. Here we have again odd numbers 1, 3, 5 all 1 plus 3 plus 5 plus 7 plus 9 and all this going up to 39 plus 41. So there are many numbers here in between. Now you don't have to write down all those numbers and count it. Now from 1 to say 39 there will be now or 1 to 40. If you're going to think of 40 as the ending number, there are 40 numbers, isn't it? But we are taking only the odd numbers. So there'll be only 20 numbers. Okay, between 1 and 40, if you're taking only the odd numbers, there'll be 20 numbers. Now this is one more odd number, so that is 20 plus 1. So totally how many numbers, odd numbers are there? From 1 right up to 41, there are 21 odd numbers. So to find the sum of that, we say 21 square. 21 square means 21 into 21. And if you multiply, you will get 441. So this is your answer. Let me tell you that once more. Now here as you can see these are all odd numbers. Now you have to count all the odd numbers up to 41 and see how many there are. Now there are 21. Now to make it easy, what we do is from 1 to 40, how many numbers are there? 40 numbers are there, isn't it? But we are taking only the odd numbers. That means half of 40 is 20. So there are 20 odd numbers and we have one more number 41 which is one more odd number. That's how we got plus 1. So totally we have 21. So to find the sum of 21 odd natural numbers, we just have to find the square of that, which is 441. So you don't have to write down all these numbers and add it up. All you have to do is find the square and get your answer. Next one, here also we have odd numbers 1 plus 3 plus 5 plus 7 and so on right up to 53. So now if we take all numbers from 1 to 50, okay, I'm talking about all numbers from 1 to 50, we have 50 numbers. Suppose you take only the odd numbers, that means half of that, which is 25. If we take all the numbers, it's 50. If we take half of it, because odd numbers are half of that, it's 25. Then we have one more number here and two more numbers. So 25 plus 2, that is 27. Now all we have to do is find the square of 27. That is 27 into 27. If you multiply, you will get 729. So this is our answer. So let me tell you that once again. Now here we have to find the sum. That means we have to add up all these numbers up to 53 and get our answer. The easy way to do it, just think and see from 1 to 50. How many numbers are there? There are 50 numbers. If we take only the odd numbers, leaving out the even numbers, we will get half of 50, which is 25. So up to 50, there are 25 odd numbers. Then we have two more here, 51 and 53. That's how we got 2. Now add up both, you get 27. Now to find how much, when you add up all this, the answer is, all you have to do is 27 square and you get 729. This is our answer. Question 15. Write three sets of Pythagorean triplets such that each set has numbers less than 30. Now, what are Pythagorean triplets? From the word triplets, we are talking about three numbers. Now, if you take any three natural numbers a, b and c, now if a square plus b square is equal to c square. That means when you take any three numbers, suppose you take the square of the first number and add it up to the square of the second number. If that is equal to the square of the third number, then we call this set of three natural numbers to be Pythagorean triplets. So it can be a square plus b square is equal to the third one, that is c square. It can also be a square plus c square is equal to b square, or it can also be c square plus b square is equal to a square, depending on the numbers. Now let's take an example. In this case, let's say a is 3, b is 4 and c is 5. Now if these conditions are satisfied, this is actually one condition, but depending on the order. If this condition is satisfied, then we can say that 3, 4 and 5 form a set of Pythagorean triplets, three numbers. Now here what we're going to do is take the biggest number, okay? So we're going to keep the biggest number aside. Now this we're going to take the square of 3, the small numbers. So 3 square, and we're going to add it up to the square of the next smallest number, 4 square. If this is equal to 5 square, okay, so I'm taking 3 square plus 4 square. If this is equal to the square of the biggest number, then we can say 3, 4 and 5 are Pythagorean triplets. So let's see, 3 threes are 9, 4 fours are 16. Now here 5 square is 25, 5 fives are 25. Let's add this up and see. 9 plus 16 is 25. So 25 is equal to 25. So here 3, 4 and 5 will form a set of Pythagorean triplets, because when we did the square of 3 and took the square of 4 and added up both, it became equal to the square of the third number. So 3, 4 and 5 are Pythagorean triplets. Now the question is, we have to write three sets. So now we've got one set, 3, 4 and 5. So let's write down that first set. So we have 3, 4 and 5. This is the first set of Pythagorean triplets. Now we have to find two more sets. We have one set. Now we have to get two more sets. Now how do we find out? It's going to be a little difficult to keep checking all numbers, isn't it? Now I'll just show you a simple way of finding. Now here I have written the tables of 3, all the answers. 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, 3 fives are 15 and so on up to 3 tens are 30. Now I'm going to write the tables of 4. 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16, 4 fives are 20 and so on till 4 tens are 40. And I'm going to write down the tables of 5. 5 ones are 5, 5 twos are 10 and so on up to 5 tens are 50. Now this is just a simple way for you to find out other triplets. Now we took the first one, 3, 4 and 5. This forms the first set of triplets that we have found here. We have worked it out. Now similarly, every number here along with the other two numbers form triplets, Pythagorean triplets. So the next set will be 6, 8 and 10. So let's write that down here. So we have 6, 8 and 10. So if you work this out, you will see that the square of 6 plus the square of 8 is equal to the square of 10. Let's work that out and see. What is 6 square? So 6 square plus 8 square should be equal to 10 square. Only then can we call them a Pythagorean triplet set. So what is 6 square? 6 is 36. So let's write that down. 36. 8 square, 8 eights are 64. Now 36 plus 64 is 100. And how much is 10 square? 10 tens are 100. So can you see how 6, 8 and 10 form a set of Pythagorean triplets? So this is the second set. Now let's go back to the tables here. So here this will form the third set, 9, 12 and 15. So let's round this up here. So the third set is 9, 12 and 15. So we have it here. Let's write it down. 9, 12 and 15. So this is the third set of Pythagorean triplets. Now we have been asked to write only 3 sets, but if you're asked to write more, you know how to get it. It's just these. So the fourth set will be, this will form another set of Pythagorean triplets. This will form another set of Pythagorean triplets. Similarly, all these form sets of Pythagorean triplets. So you have 3 numbers here in each, and they form Pythagorean triplets. So this is just one trick for you to get all your numbers easily. Now the question says each set should have numbers less than 30. So we got numbers, all 3 numbers are less than 30. That means you stop here. If you want to get more, you stop with 15, 20 and 25. So you can do this, children, so that you can easily get your Pythagorean triplets. So with this, we have come to the end of this exercise. Thank you, children.